All right, I'm going to talk for a little bit today and go back to the book because I just don't want us to lose focus too much on the book itself. All right, just so you know, I'm not sure how long this talk will take. I'm not sure what we'll do Thursday or Wednesday right now, but next week, um, we're going to be writing the same project both as an iOS app and as an Android app. All right, so it'll be that tip calculator. So um, you get a chance to really see, kind of compare whatever the two of them side by side. All right, and it's lab all week in Java. All right. So just mention a couple things from this book. Not too much. It's not a bad book. It's not a good book. It's just a book. All right. They do a pretty good job in here of explaining, what you're supposed to learn from this book and how the book is organized, etc. And it's kind of weird because it's just the last couple chapters. Almost the entire book is on part one and part two. Almost the entire book. And then just at the end they go through some of the other stuff. I guess if I had it to do all over again, would I have got this book? Probably not. And one reason is that virtually every example that they show in here up until the last couple chapters, they're all command line. All right. I like the way the guy writes. I like the book. There's a lot of good stuff in it, but there may have been a better one that I could have gotten. I'm not going to read through this with you, but you can see when you look on the bottom of page 3 and you go on to all of page 4, they explain to you how the book is laid out chapter by chapter. All right. Yeah, not my intention to go do that with you. All right. Am I right now in assuming when you look at this program that they show here, and this is from page 7 in the book, and I'm asking this, am I right in assuming that people understand what this is? This whole program. Let's just break it down line by line. The comment, hopefully that's a given. You do comments the same way that you do them in C, the same way that you do them in Java, etc. That's all it's going to do out in the console. So the first line's a comment. The next line, again, what you're going to find out is usually when you do command line programming, you import foundation/foundation.h, and when you do GUI program, it'll be Cocoa. So you'll see it as we go on. Yes. We're going to get into that, and it's not very different from the way you do it in C. All right. You can add stuff in there. You can do a %D in there, %F, the same kind of way that we've done it in the past. So remember the difference between an import and an include. The import checks to see if the file's already been included, and if it has been, it doesn't include it again. All right. Talked about this before. This is the argument count, and that's each one of the arguments. They're put inside of a string array. This, again, basically says that rather than us being in charge of the retain and release count, we're going to let the system keep track. And again, just a log statement, so that'll write it down to the console. If we're using Xcode, for example, down in the bottom center of the screen, it'll just say programming is fun. All right. Not going to go through the Xcode stuff because we've already talked about it. You've already done a project with it, so I don't really see the advantage of it. Again, they go through and they talk about the different things, how you can fill them out, etc. So if you're more interested in, or looking, getting another view on it or whatever, it's right there. I think I mentioned this before. This is the bottom of page 12. Again, here's your major extensions. Almost exclusively, the two that you'll use 99% of the time are .h and .m. Okay, those are the only ones really you have to worry about. And again, hopefully you realize that even with main, main was called main.m. It's not main.c. All right, and there is no main.h. It's just the main.m. There's the old famous or infamous hello world. Okay. And this is what you kind of asked about, Mike. This, not exactly, but this is right here. That's exactly where it's going to print. That's your console area right there. You can move it around a little bit, but I wouldn't recommend doing that. Okay, they talk about errors on the bottom here of page 14. And again, the idea is, it says there, if you do make mistakes along the way, you'll see errors denoted as red stop signs. Some of you have already noticed this when you bid an Xcode. All right, it may look red, it may look pink. But what will happen is you can still compile the program, but what Xcode is letting you know is there's something in there that's going to keep it from compiling cleanly. Hopefully you've already gotten a little bit accustomed to the fact, for example, if I'm sitting there and I'm typing something in, and here I put nslog and I make the L lowercase instead of uppercase, I'm going to get something off to the side there that's going to show me the fact that that's an error, because this is all totally case sensitive. All right. And that's again what it's going to look like in your console log. So they have you create that application. They go through terminal. Again, I've mentioned this to you before. Terminal starting on the bottom of page 16, and it goes on all the way through page 18. That's the equivalent of what we've been doing when we're in here. Oh, I thought it was on the virtual desktop. But when we're in here in the virtual desktop, and we come in, what I'm going to do too is I'll talk till about 4, all right? Then we'll take a break. Then after the break, we're going to do a project that's actually simpler than the ones that we did the other day. And then when we get done with that, I'm going to give you a handout and ask you to try to do one on your own. All right, something I found online. It's got all the code in it and stuff too. And I just thought it might be something that you'd like to try. Okay? So remember this from C, that's the equivalent of terminal. So if you want to do everything from a command line, you're able to do so. Since you've got Xcode and since Xcode is a visual editor, I don't understand why you'd want to use this, but you can. All right, if you don't like my explanation of the first program, if you look on the bottom of page 18, all of page 19, all of page 20, page 21, they explain what's happening in here. All right, again, I don't want to read this to you. Talk about comments, why you should comment. They talk about the import statement, all right, and the difference between import and include. Then on the middle or down towards the bottom of page 20, they explain what this auto release pool is. You can take a look at that yourselves. I'm sure that's explained to you much better than the way I just explained it. Notice too on the very bottom of page 20, here the @ sign immediately precedes a string of characters enclosed in a pair of double quotes. Collectively, this is known as a constant NS string object. So that's literally saying print the string object, programming is fun. And in that case, if it's put in there with nslog at the console. And they give you another example where you can have it twice. Programming in C is fun. Programming in Objective-C is even more fun. The backslash and, you know this. Okay, Mike, this is what you asked about. Again, when you do this, you can use either %I or you can use %D. Not only that, even though your instructor may not have told you this, you could have used %I in the regular C class. It would work just the same way. D actually stands for decimal integer. And almost always in the workplace, you see %D. You very rarely see %I. That's why I encouraged you to use %D. NSLog we're swapping that out, or swapping out printf and swapping in NSLog, and yeah, you need the @ sign. Yeah. But again, you'll need to have, for each one of these, you know, if you're going to have 2% things over here, you need to have to them over here, type of an idea. Also, just so you all know, I graded all your C stuff. It's all out there. Now, you had 4 programs. Some people only did 3. I don't know why, but some people only did 3. All right, so if you only did 3 and the 3 were okay, you got 40 out of 50. And the one that people seem to not do was that inventory one. Now, if you go raise your hand, well, you told us we didn't have to do that. I don't remember ever saying that. And if I did say that, then tell me why 7 out of 9 people or 6 out of 9 did all 4, and 2 or 3 just did 3. Because I don't understand that. All right. I've done midterm grades already, and even if you turned in very little so far, you're still getting an S. It's much easier for me to just go S that way. All right, I can't do that with the first year people because with a lot of them, this is the first assignment they've had. I don't know them. You know, there's some people in here that have done one or none of the assignments, but I know they're good and they'll do them as soon as they get the chance. That's a hint for those of you who haven't done them. Okay. So here's another one: percent I, percent I, percent I. Okay. All right. And the good news is, probably just about everything that you've seen in here so far, it's nothing new. I don't want to sit there and read to you anymore about what an object is. All right, we've talked about this. You either get it or you don't. All right. He talks about cars in here. That seems to be a really popular one for using for Objective-C programs. All right. By now, hopefully you're aware of this. Again, we've talked about this before. You know, the syntax for calling a method. The name of the object, the name of the method, both inside of brackets. And it's mentioned there, it can appear both on the left and the right-hand side. All right, not really on the left-hand side of an equal sign, but you can take the result of it and assign it to something. All right. What he does in here, what Kochan does in his book is as he says, he writes an Objective-C class for working with fractions. But he starts real simple. What he does is he declares a variable called denominator, and he sets it equal to, he set one called numerator, and he sets it equal to 1. Then he creates another variable called denominator, and he sets it to 3. And he just puts 1 over the other one with a slash in between and says, now you're done. I don't know exactly what he's trying to show you here, all right? But that's it. He's not really doing math, but one of the things that he's showing you there, and the example's not bad, all right, but one of the things that he is showing you there is it is literally possible for you to write and still put everything inside a main. You virtually never see anything inside of main that you write. Almost always, the only thing that main holds is the auto release, maybe a log statement, and a return 0. Other than that, there's usually don't write anything in main. Does this look familiar to people by now? I'm asking, because I really and truly want to know this. When you look at this, does what's in here make sense where I'm going? That's the interface, so you know that's going to be the .h file. So what we're doing here, right there, is we're declaring 3 different methods. All right, they're all instance methods. So in other words, every time I create an object of that class, it'll have one of these methods associated with it. The minus sign means that it's an instance method. So you have to have an instance of the class that you've created in order to be able to call the method. If there's a plus sign there, that means it's a class method. If it's a class method, you can call it directly without even having to create an object of that type of class. All right. So you can see their names are print, set numerator, set denominator. Since print does not require any parameters, it's okay to put it like that without parentheses. That's different between C and Objective-C. You can't do that in regular C. All right. You still can put the parens in there if you want to. It doesn't hurt anything to do it. So set numerator requires an integer, all right, to be passed in, and inside of that method, set numerator, that integer will be referred to as n. Set denominator requires an integer passed into it, and that inside of that method, it'll be referred to as D. That should make sense now, by now, to every one of you in here. All right? Yes. Almost the same way you do it in C. Yeah, you will see it. Not only that, it's one of the times you can actually use the same syntax you use in C. So the name of the object dot the name of the structure member, you can do that in here. All right, so here, as it says, there's the implementation. Okay, so here's the class fraction. There's a numerator, there's a denominator. Okay? And what are we doing here? In print, we're printing one over the other one. In set numerator, we're setting the numerator, and set denominator, we're setting the denominator. That's all. So now if you do it this way, which is kind of a weird way of coding, but the author is showing you here that if you do it that way, that you can put stuff inside of main. And we looked at this the other day, but just so you remember, this right here, these two lines where I'm putting the mouse around, it's totally legit to put those in there as one line of code. Not only that, you'll almost always see it as one line of code, where it'll say my fraction equals, then there'll be two of these left brackets, fraction alloc, and it'll end, and then init with another right bracket, just like we looked at the other day. All right. Again, once we've created a fraction object, then we can go and call its methods. All right. This is doing the exact same thing that we did before by putting it in main. All right. It's going to be exactly the same as putting everything else in main. All right. The question always gets asked, then, well, that's fine. Then why the hell don't we just put everything in main? Because after a while, main gets too big. And if you're creating a program of any size, the chances are really good you're going to have several people working on it. But the worst thing you can do is when you're working on a program, when there's several people working on it, is having them be working on the same routine at the same time. In fact, some software, depending on the versioning control, etc., won't even let you do that. All right. I managed to write some code years ago, some C code, and I wrote it, and this was on me, all right, and I took the blame for it. I wrote it and was testing it, but didn't finish testing, and then somebody in the office said, let's go to lunch, and we did. And we came back later. All right. While I was at lunch, somebody else in another country, it was in England, came in on my code and actually put some of his code, half of it was inside of my code, and half of it was outside of my code. So when I saved everything, it screwed up his code. And I get this guy, you know, that was, maybe I told you this already, but because I just had to laugh because I'd never heard it pronounced like that before. You know, I can't do an English accent, but this guy calls me from England. He's like, hey, mate, you screwed up me tuples. And I had no idea what the hell he was talking about. And I said, how do you, tuples, what is that? He goes, tuples, T-U-P-L-E-S. I said, no, tuples, yeah, tuples. All right. So the point is, if I'd done a better job of version control, and this was many years ago, if I just saved it and gotten out, there wouldn't have been the problem. All right. But again, you see, you get the same exact thing as if you put everything in main. But the author is trying to sell you here on what you want to do and why you want to do it. So this stuff that's in here right now, again, I don't want to read it to you. That paragraph is probably the most important paragraph up till this point in the book. It's on page 33. And you should understand what happens in every one of those sections. Main usually is referred to as the program section. All right? But you should understand by now the difference between an interface, which again is a .h file, and an implementation, which is a .m file. Again, each part of each of these sections is a part of every C program. Then he goes in and he talks about them in more detail. This is where, for lack of better words, it gets a little funky, because there's always more than one way of writing the same kind of code. So he talks about the interface here. As he says, when you define a new class, all right, you have to tell the compiler where the class came from. That is, you have to tell its parent class. That's what you see right there. Again, if you don't know where it comes from NSObject. All right, but in the example that we just did, in the C program, I'm not going to have you redo that or anything, but in that C program, one of the ones you had to do was were those employees. And if you remember that, we had what? Manager, hourly worker, piece worker, and commission worker. What we could have done is we could have had a class at the beginning that we used and called that employee and said all employees have an employee number, whatever. They have, an employee first name, an employee last name, etc. Then what we could have done is we could have extended employee to create manager, extended employee again to create hourly, extended employee again to create commission, and extended employee again to create piece worker. We could have done that. All right? We didn't. So essentially all of them extended the object class. Again, by convention, class names begin with an uppercase character, but it's not required. Even though it's not required, do it anyway. The rules are the same rules that we learn in C, so we don't even have to go through those. Okay. All right. So again, he talks about this. I already mentioned it to you. These are the three methods that the class is going to have. They're all instance methods. None of them return anything. Two of them need to have an integer passed in. You already saw that in the example. Right? Here they go through talking about the minus versus the plus. This is all stuff, and again, I'm not trying to waste my time. I'm not trying to waste your time. But I'm assuming when we get back into the code, all this makes sense. And if it doesn't, you're going to go back and read it so that it makes sense. Again, in the examples that we just saw, all of the return values were void, but they don't have to be. And when you look right here, if you look at these examples, because there's only three of them, returning an int, returning a double, returning a void. You can return virtually anything you want. What you can put in there if you want to is you can put a name of a class in there. You can return an entire class. So you can call a function, and that function can return an entire class. But only one class, because as you know, a function or a method can only return one thing. All right? Another important piece here on page 37. Yeah, go ahead. As far as? Well, see, I'll answer. You tell me if I've answered your question, okay? Technically, C doesn't support classes. It doesn't support the idea of a class because it's not an object-oriented language. You can pass back an entire structure in C, so that you can do. But since C really doesn't, it's not object-oriented. So there's no real equivalent of a class, so to speak. I guess a structure would be about as close as you can get. Yes, you can pass an entire structure in or back from a method. Okay. So again, the implementation section, that's where your actual code resides. All right. Now, you already saw this. And I want to make sure that everybody gets this. I'll go back a couple pages here. Even more than that. All right, you already saw this stuff. What I want you to understand, though, those minuses right there, okay, because, for instance, if you're talking about some programming languages or you're talking about a language, bless you, like UML, the Unified Modeling Language, those minuses mean private. That's not what this means. I want to make sure you get that. That does not mean private. All right, technically, those are public methods. Because if they're defined inside of, if you would define them inside of the .h file like that, they're technically public methods. So it's possible to call those methods from outside, from other classes. Did you hear what I just said? All right. So if you say, well, that's fine, I don't want to do that. I want to literally set it up so I want them to be private. I don't want anybody outside of here to even know that they exist. Well then, if you want to do that, it is totally legal that right inside of your implementation, you can create stuff in there. So if you create a variable inside of your implementation section, not in your interface, not in your .h, but in your implementation, in your .m, it's private. Otherwise, it's considered to be public. All right. So again, hopefully you're able to look at something like this. So now, as I mentioned, since we set them inside of the implementation, they're private. But there really shouldn't be anything in here, hopefully. Other than that, it looks the same as what we saw before. All right, and again, what he calls the program section, that's where you've got to do something. You've got to do some kind of allocation in here, and that's what we're doing right there. And again, although the author shows you that as 2 lines, it can easily be done as 1. It doesn't matter. You can do it as 2 lines. It doesn't hurt anything at all to do it that way. The other thing, too, is if you look in here, how many times in this routine do you see the asterisk used with my fraction? I see it once. And that's when you're doing the declaration. Anytime you're actually using it, you don't use that asterisk. All right? Even though it's a pointer, you're not using the asterisk all over the place like you were in C. And again, what this is saying right here, this first line that you see that I'm putting the mouse over back and forth, that says, okay, I want you to allocate enough memory for me to hold a fraction. And what's a fraction? Well, you can already see that from down here. We already saw what it had in it. It had a denominator and a numerator. All right? And now it says, basically, call the init method. What the init method does, it's kind of right there. That's kind of like a super. And if you do nothing else, it initializes it. It's supposed to initialize numeric variables to 0. It's supposed to initialize Boolean variables to false and string variables to the empty string. Does that make sense? No, that's like Java's super. We're going to get set, no pun intended. So again, they explain here what's happening in each one of the lines. All right. And again, that's almost always the way that you see it done, is like this. So it's the name of the class, the name of the object with an asterisk before it, equals, bracket, bracket, the name of the class, alloc, ending bracket, init, ending bracket. That's the same thing as those 2 lines that you saw previously. And you're going to see this throughout this book, and if you read enough in here, you're going to see this kind of thing too, this right here. They talk about the release pool, and I mentioned that to you already. You don't have to worry about it anymore. Starting with Xcode 5, they decided that it was just too much, that unless you really know what you're doing, unless you're really an experienced programmer, let the system do all the retains and releases for you. All right? And that's ARC, that's automatic reference counting. Yes. Well, tell me if I'm answering your question, okay? So I think what you're saying is you don't want it 0. You want it to be something else. Then you can override the init method. We're going to get to that. So again, another good page, page 42 here. They explain what that asterisk is and how it's being used. And they even show it to you that once you do that, again, my fraction is going to point. Since, again, we haven't set it equal to anything other than a init, like I mentioned, they're both 0. Okay. The other thing, too, is, to answer your question, Zane, is typically what happens in here is when you come in here and you do this, the next thing you do is you call something that's going to set it for you anyway. All right? But you can override the init. Okay, but it's more often than not you're going to see it done like this than overriding a init. Yes. Yeah. Yeah. There's ways of defaulting it. There's a lot of different ways that it can be done, and we'll look at some of that as we go on. So in this case, all we're doing is we're creating 2 different fraction objects frac 1 and frac 2. Frac 1 will be 2/3. Frac 2 will be 3/7. Okay? So they're initializing them there and there. They're printing out the first one. Excuse me, they're printing out the second one. And that's what you get. He's not really doing any math. He's just putting one over the other one. Accessing instance variables and data encapsulation here. All right. On the bottom of page 45. Again, I was reading this article the other day. It was, I don't remember, it was ASP.net. It was one of these things that was on Code Project that have interview questions. And they said that if you're applying for a job that as a programmer and the language that you're applying for is an object-oriented language, you can feel fairly certain that you will be asked what data encapsulation is. All right? And you all know what data encapsulation is. Really, when something is encapsulated from you, it's hidden from you. So bottom line is, when you look at this, I'm not to be funny or anything else, I don't know exactly what's happening in both those lines. I know that it's initializing it's allocating space for an object and it's initializing it. But internally, in the computer itself, I don't know what's happening. That's been encapsulated from me. All right, because it's one of those things I'm probably better off not knowing, because then I can't screw it up. All right. So you'd asked before, or not asked, but Mike mentioned about the set. You can write set routines. You can write get routines. You can in here, or you can have them written for you. All right, we'll look at both. But here's an example of, there's your sets, and this looks a little weird, doesn't it? Because typically when you write your gets, you don't use the word get. Notice what it's called. Notice what it's returning. That's legal in this language. So the get routine, you literally leave the word get off and you just use the name of the variable that you want to return. And then you just return it. Like I said, it looks a little funky, but that's just the way it works. Also, just so you know in here, you'll notice that you can have a space in between the minus and the paren here. You don't have to. Literally, we could have run all this stuff together with no spaces whatsoever, and it would have worked just fine. You've heard me say this again and again. Just establish a standard, something that you're comfortable with, and just do it that way. That's the best thing I can tell you. It's not that any one way of doing it is better than any other way. So they talk about getters and setters in here, okay? All right. Now the whole next chapter, I'm not going to go over one page of it. Okay, because what is it? This is an int, this is a float, all right, etc. In fact, I lied. I'm going to go all the way up to page 65, so I'm going to go up 14 pages into the chapter where there's something with a little meat in it. All right, it says now it's time to define a new class. We're going to make a calculator class, which has got a simple 4-function calculator. So far, all they've done is they've created fractions. They've done no math with them. But they want to be able, as it says here, to add fractions, multiply fractions, subtract fractions, and divide them. All right. As it says, similar to a regular total, you must keep track of the running total, and that's what we'll call our accumulator. All right. We'll set the accumulator to a specific value, clear it by setting it to 0, and retrieve it when we're done. So what I'm telling you is now you should be able to look here. This is on page 65 in the book, but you should be able to look at that entire thing and read it and understand what's happening in there. Right? And you say, well, I can't. Then I'd go back and read the chapter. I mean, and again, I know this is me putting on the teaching hat. Yeah, you got to say stuff like that, Jeff. Yep, it's true. But you can learn to do this stuff. Everybody in this room can learn to do this stuff. But if you learn to do it and you haven't read the book and you really don't understand what you just did, you're not helping yourself. It's not going to help you any. And it's going to get even worse because it's real easy to just start doing stuff in Swift and not know anything. Oh, I wonder what would happen if I do this. So you type it in and boom, on the side of the screen it shows you. Which is either really good or really bad depending on your point of view. Somewhere in my mess of stuff here, this was in uh, developer.telerik.com, and it's not a long article, it's 4 pages. Why iOS developers still need to know Objective-C. All right, and I just glanced through it very quickly, but what the guy's saying is the stuff, even in Swift, is built off of this. All right, and it's the idea that if something doesn't work in Swift and you want to be able to write your own routine to do it, it's going to be much easier if you've got at least somewhat of an Objective-C background. So he actually does the math in here. Okay. The next chapter we can skip. It's on for loop, while loop, and do loop. There is absolutely nothing in this chapter that I saw that was new. They do mention on page 80, and I'm not going to turn there, but you can use scanf here if you want to. Okay? And they talk about break and continue. So nothing new in there. Turning up all the way to page 93. Making decisions. If, switch, and conditional, which is the question mark colon operator. Again, nothing new. All right? He does have a pretty good program in here. I mean, he keeps going on with this calculator. So if you do look at the program that's in here, he keeps adding to it. So here's his fraction class. You can see the stuff that's in it. And when you go on, he's making sure that you don't divide by 0. But you should, again, be able to look at this, and hopefully it makes sense to you. The other thing on pages 102 and 103, he's got a real little mini leap year program. So if you're still having problems with leap year stuff, you could take a look at that. All right. And that gets us through page 126, the first 6 chapters of the book. All right. It's early, but let's take a break now. Let's come back at 5:02, and I'm going to give you an example. And then we're going to bring the machines out, and I'll let you play for the rest of the class.